Hi Precalc students, this is just a really quick video to show you another way of solving systems of nonlinear equations. On the Georgia Virtual website, you were solving systems that had a conic and then a straight line, and you were able to use substitution for all of those. However, on the assignment, you have conics where you have a system with maybe that has an ellipse and a parabola, or a circle and a hyperbola, or something like that. So you have to use another way of solving a system, which is elimination rather than substitution. So I'm going to walk you through the number one on the assignment to kind of help you get started. The first thing you want to do is think about the equation and think about what type of conic is being represented, so you can kind of visualize what it's going to look like. So if you look at this first equation, we have a 9x squared and a 32y squared. That's telling you you've got an x squared and a y squared, and those two coefficients are different. So this is going to be an ellipse. And the next one, we have an x squared and a y squared. One is positive and one's negative. So that tells us that it's going to be a hyperbola. So you want to think about how those could intersect each other, and it's going to help us when we get to the last part to match them up to find our intersection points. That's going to help us. So for elimination, you want to try and eliminate one of your variables. So either the x's or the y's. In this case, each equation only has an x squared and a y squared. There's not also a term that has just an x or a y. If there was such an equation, you would want to eliminate the other variable. So in this case, we can eliminate either the x or the y. Probably the easiest thing to do would be to eliminate the x squareds here, and you need to try and make those two coefficients the same. So, well, the same number, but the opposite sign. So if this is a 9, you would want to make this a -9, so you would be able to eliminate those. So I would recommend taking this second equation and multiplying it by a -3. So you're going to get -9x squared plus 3y squared equals -9. And then I'm just going to rewrite my first equation underneath there. And then I'm going to add. Now my x squared terms, they're going to eliminate. This is going to give me 35y squared, and -9 plus 324 is going to give me 315. I'm going to divide both sides by 35, and I'm going to get y squared equals 9. And then I'm going to take the square root of both sides, and when I do that, I'm going to get two possible solutions, either positive or -3. So that tells me that my intersection point is going to, or points, is going to be where y equals -3. My next job is to try and find the x coordinate, so I'm going to substitute that back into one of the two equations up here. It doesn't matter which one, pick the one that's going to be the easiest. I'm going to put it into 3x squared minus y squared equals 3, and you're going to need to substitute both of those y values in here. It turns out that no matter whether you put in a 3 here or a -3, it's going to give you the same thing. That would give you 9. And then you're going to just solve this equation, and you would get x squared equals divided by one step ahead of myself. X squared equals 4, and then you take the square root of both sides, and you would get x equals positive or -2. So those would be your solutions for x. Those would be your solutions for y. So this actually means you're going to end up with 4 possible intersection points, and I'm going to show you what the graph would look like. It's going to match up with this one right here. We have our ellipse, we have a hyperbola. They're going to intersect at 2, 3, and to -3, and also at -2, 3, and -2, -3. So once you find your intersection points, you want to match it up with one of the graphs. Label the intersection points on the graph. All right, hope that helped.